Hi everyone. Today we're gonna look at natural language inference, one specific task that's common in natural language processing, and introduce our homework. Okay, so natural language inference is a task in, as I just said, in NLP, where the question is, it's a three-way classification task, where the question is giving a context. A context is a sentence already. Then another sentence, another statement can be either correct, which is then called entailment. It can be incorrect, which is a contradiction, or it can be neither. So you cannot say whether it's correct or incorrect. This would be a neutral case. So maybe for a simple example, a guitarist is playing in a band, is the context. And then the statement is, some people are performing. And now we have to decide, is the statement correct or incorrect or neither? And in this example, it's clear that it is correct, it's entailment. If a guitarist is playing in a band, people are performing in a band. Because, I mean, a band is multiple people, so some people are performing because at least the guitarist is performing with his band. There might also be other examples that are not that clear, however. For example, here, a black and white dog running through shallow water. The statement then is two dogs running through water. And if we look at the distribution of votes that we observe, we see that out of 100 people, 42 people think this sentence is correct, because they think there are just two dogs, one black dog and one white dog. 14 people think it's neutral, that you cannot really say what it is. And 44 people think it's wrong because it's a single dog that's both black and white. And here you can already see that even though the task is kind of simple, since the grammar in the sentence is not really perfect, it leaves some ambiguity to what is actually meant here. Is it a single dog or is it two dogs? And you can see that all of the annotators, or most of the annotators, have a strong opinion whether it's two dogs or not, because only 14 people say it's neutral. But there is a big amount of disagreement, of human label variation present. And what I want you to do as a homework is to analyze a data set that contains many examples of such sentence pairs. And I want you to figure out, find examples where you can see that there is this disagreement. I want you to think about how would you label this example and really see how difficult it can be, even as a person that tries to give the right answer, to give a right answer in this case, and in this way figure out that this human label variation actually is meaningful, is plausible, and is really difficult. What you will get is a Jupyter notebook that is hosted on Google Colab, where you have access to a plot like that. That contains 1,500 examples of such sentence pairs. And how you can read such a ternary plot, so this triangle plot, is that you have those three axes here on the left side, on the right side, and on the bottom. And basically here on the left side is the scale that goes up to entailment. So points that are here in this very corner have 100% entailment. Again, points in this very corner have 100% of votes are for contradiction. Points in this corner have 100% votes for neutral. And if we, for example, go up here, 20% entailment, and go a little to the diagonal down, 80% here, like points that are directly here, have 20% entailment and 80% neutral. And basically every point here represents like a location on the distribution. For example, the one here in the middle, here you can see it has 35 votes for entailment. You can read it like that because it is somewhere here is a horizontal line, 35% entailment. 31 are neutral. It's because if you go here, it's neutral, and 34 are contradiction. So this is the axis for contradiction. Okay, so each point represents one instance. The location is determined by the vote distribution, and the corner points are the obvious ones. Okay, now I'm gonna show you how this looks like. So you have a Jupyter notebook. We can go here to the very top. First, I want you to save a copy in Drive. So you have your own copy. Then you can choose here, just click on Run All. It will take some time to download the data, so maybe it takes about a minute to download the data. And then here it's just some code for plotting. You don't need to care about it. All I want you to care about is here, this graphic. So it's an interactive graphic, so you can go through all the examples that we have here. And if you find an interesting example, like the one in the video before, an elderly woman crafts a design on the loom, the woman is sewing. I want you to click on it. Once you click on it, it gets collected here in this table, and the task is, where is it, the task? Oh no, here, sorry, I put it on the wrong. I will move the one down for you, I'm sorry. Here, your task is explore examples near a vertex, an edge, or the center of the simplex. Choose at least 2 examples whose majority label you disagree with. One with a close or ambiguous vote distribution. So for example, I'm choosing the example with the woman on a loom. I think, for me personally, I would say this is a clear contradiction because in my opinion, using a loom, weaving on a loom is something different than sewing. That's why I can say, this is the example, here you can check the number. I say it's contradiction, and then I explain in 2 to 4 sentences. I think weaving on a loom is not the same as sewing. Then it's already collected here. I can click on another example, just choose some label and write something, test. And then you can go through as many examples as you think. Just think about some of them. If you clicked on an example that you don't really want to talk, you can clear the all selected examples. So it's important if you click this button, you clear all of them. So maybe at first choose some of the examples and then write down. And then I want you to download this completed file. So it downloads a CSV, and this CSV you will send to us by email. Okay, and after this example, after you did this exercise, I hope that you will see that ambiguity and human label variation can be very well a property of data sets, and see, like after if you've analyzed it, see that it actually happens, and maybe while you do that, think about examples that you already worked on. Is there human label variation present as well? Okay. We are funded by the DFG and copyright by everyone.